Hello, we are discussing about GATE 2002 ECE paper for the given 8085 microprocessor with 5 MHz clock frequency. We are going to find what are the total number of machine cycles required to execute the routine till the jump instruction is executed for the first time. If you observe the program, jump is the last instruction, and it is going to the first instruction in the program. That means to execute a loop, how much time it requires, how many number of machine cycles it requires, that we are going to calculate. So the number of machine cycles required to execute that subroutine, we are going to calculate. And next one, determine the time interval between two consecutive memory write signals. Third one, if external logic is controlling ready signal such that 3 wait states are introduced in IO write machine cycle, find the time interval between two consecutive memory write signals. These are the 3 things we are going to calculate. Before going to calculate, first I will write for each instruction how many bytes the instruction will take, how many machine cycles it will take, what are the T states, and what are the type of machine cycles also I will write. From that one we can easily calculate these 3 things. So look at this one. First I am going to write how many bytes of instruction it is. Next, what are the number of T states it requires. Otherwise, first I will write the machine cycles. Machine cycles it requires, number of T states it requires, and type of machine cycles, that is, these are machine cycles operation. So first, move A comma B is a single byte instruction. Move A comma B is a single byte instruction. It takes 1 machine cycle and 4 T states. That 1 machine cycle is always called as fetch cycle. F means fetch cycle, that is opcode fetch. If an instruction is consisting of only 1 byte, that must be always opcode fetch cycle only. So F indicates, F means opcode fetch cycle. Opcode fetch cycle with 4 T states. Whereas some instructions are going to be taking for the same opcode fetch, it takes 60 states. By that time, opcode fetch cycle with 60 states is indicated with letter capital S. And second, out FFH. Out FFH is a 2 byte instruction. It takes 2 machine cycles. It takes 3 machine cycles. And number of T states it required is 10. So here, out 55H. The meaning of out 55H means this instruction will copy the contents of accumulator into port number 55H, the port addressed by the 55H address. So out 55H is making contents of accumulator to be placed at 55H port. For that one, first it will understand what the instruction is going to do with the help of opcode. So it requires a fetch cycle, opcode fetch, and afterwards it must know from opcode fetch, it understands that one, the microprocessor has to place the contents of accumulator at an output port. But what is the address of output port? That it will know in the second machine cycle, which is nothing but memory read. R means memory read. Memory read, it is reading from the memory, that is that 55H will be in the memory, that 55H will be read from the memory in the second machine cycle. And after knowing the port number, now during third machine cycle, it is copying the contents of accumulator into that output port 55H. So copying contents of accumulator into output, that is, it is going to write information into output ports. It is sending the information. That means it looks like it is going to write information on output port. So it will be consisting of IO write operation. So out FFH, out 55H will be consisting of first opcode fetch. Okay. From opcode fetch, microprocessor will know what is the type of instruction it's going to perform. What is the type of operation the microprocessor has to handle, that it is going to find. And afterwards, after knowing that one, it has to write some information present in the accumulator to the output port. It wants to know the output address. That output address can be known from memory read cycle, that is FR, second machine cycle. And after knowing the port address, it will write the information present in the accumulator on the output port, which is nothing but IO read operation. So R means memory read operation, memory read cycle, and O means IO write machine cycle, IO write machine cycle. Next, DCB is a third instruction. DCB is decrement B, which is a 1 byte instruction. 1 byte instruction, 1 machine cycle and 4 T states. Whenever it is 1 byte instruction, always it is opcode fetch only, but it is taking only 4 T states. That's why it is indicated with F. F indicates opcode fetch machine cycle with 4 T states. Next one is STA FFF8H. It's a 3 byte instruction. It's a 3 byte instruction where it is taking 4 machine cycles and 13 T states it takes. 13 T states. So always first one is nothing but opcode fetch. STAFF8H. STAFF8H. So store accumulator contents at the memory specified on the instruction. So from the opcode fetch, the microprocessor understands that one, it is going to place accumulator contents. It is going to place accumulator contents at some memory address, at some memory location. The memory location is specified in the instruction. That is nothing but first is opcode fetch. Okay, from that one it will know this information, and during the next cycle it is going to get the address. It's going to get the address. Okay, for the first time it is going to get the lower order address and later higher order address. It will take 2 memory read operations. Since 8085 is a 8-bit microprocessor, it can read only one 8-bit data at a time. So to read 2 8 bits of information, because the memory address is 16 bits, it requires 2 8 bits. Okay, so it will read 8 bits at a time through data bus. So it takes 2 memory read operations. Later, this accumulator, during 4th machine cycle, the contents of accumulator are placed onto memory location. That is, now the microprocessor is writing the contents of accumulator into memory. So this will be called as memory write operation, W. Memory write operation. Previously, if you observe out FFH, where the microprocessor is writing the contents of accumulator into output ports. Now STA instruction, microprocessor will write the contents from accumulator to memory location. So this is also write operation, that is also write operation, but that is writing into output port, this is writing into memory location. That's why it is called as memory write operation. This is memory write operation. So it takes the signal as memory write bar. It requires the signal during this operation. During this machine cycle, microprocessor generate MEMW signal, memory write. So STA requires 4 machine cycles. First one is opcode fetch, second one is memory read operation, third one is memory read operation, and the 4th machine cycle is memory write operation. Next, jump start. Jump start is again 3 byte instruction. Unconditional jump is 3 byte instruction. It takes 3 machine cycles and 10 T states. So for this one, this jump start is decoded as jump some memory location. Start is a label at which start label is there. It will find the memory address. Okay, it will find the address location of start label, and later it will be equal to jump that memory address. So first one is opcode fetch. From this opcode fetch, microprocessor know that one. It has to make the sequence. It has to make the program sequence to jump to some memory location which is specified in the instruction itself. So to get that memory address, again memory address is 16 bit, so it requires 2 read operations. Jump memory address. Okay, so this can be written as FRR. Jump start requires 3 machine cycles. First machine cycle is opcode fetch. Second machine cycle is memory read. Third instruction is memory read. Memory read means it is reading 8-bit data from the memory location. Okay. So now we are going to find total number of machine cycles required to execute the routine till the jump instruction is executed for the first time. If the jump instruction is going to be executed for the first time, the routine starts from this one. So 1, 2, 3, 4, 5. That's all. We should not consider the second time move out DCR STE. The jump instruction is first time it is executing at this point, that is starting from move AB 1, 3, 4, 5, 9 plus 3, 12. So it requires 12 machine cycles. 12 machine cycles it requires to execute the routine till the jump instruction. So if you observe the second loop also, again the same 12 machine cycles are required. Okay. Next, determine the time interval between 2 consecutive memory write operations. Memory write operations are going to be performed at STA, where memory write signal appears this point. Remember this one. There is no memory write operation in the entire routine. Okay, only one memory write operation is required while executing STA instruction. So between 2 consecutive memory write operations, that means one memory write instruction from the first iteration and second memory write is going to be coming from the second iteration. Otherwise, memory write from the second iteration and memory write of third iteration. Like this, 2 consecutive memory write signals you must consider from 2 iterations. So definitely you are going to get these cycles. Okay, that means you are going to consider the memory write from this point again up to this point. So after this memory write you are getting, okay, how many machine cycles? These 3 machine cycles. Okay, determine the time interval between 2 consecutive memory write signals. So we don't consider the machine cycles, we will directly consider the T states. Okay, time interval between the 2 consecutive memory write signals is nothing but how many number of T states it is taking. So first it is taking, after STA it is taking jump instruction that requires 10 T states, and later move AB which requires 4 T states. Next, out instruction it takes 10 T states. Next, DCB instruction it takes 4 T states. Next, STA instruction, because previously it was not considered, so now we must consider that one, it is taking 13 T states. So this is STA instruction. The total is 14, 14, 28, 28, 38 plus 3, 41 machine cycles. 41 T states it takes. So 1 T state is nothing but 1 complete cycle. Okay, 1 complete cycle, and 41 T state means 41 cycles it is taking. So 41 cycles, each cycle is So 41 T states, and each T state is nothing but 1 by F frequency, 1 by 5 megahertz. So this will be treated as 0.2 microseconds. 1 by 5 means 2. So total is nothing but 41 into 2 is 82. So this will be 8.2 microseconds time it takes. The time interval between the two consecutive memory write signals is 8.2 microseconds. And if external logic, now the third one, if the external logic is controlling the ready signal such that 3 wait states are introduced in the IO write machine cycle, because the output port communication, output port is taking too much time, it is very slow when compared to the microprocessor. By that time microprocessor will wait for the communication to complete, then microprocessor introduces some wait states. By that time, if 3 wait states are going to be added in IO write cycle, so this will become, previously it is 3 cycles it requires, but now extra 3 cycles are added. That means 6 plus 3, 9 plus 4 is 13. So 10 plus 3, now this will become 13. If 3 wait states are added at IO write cycle, then IO write cycle takes 6 T states instead of 3 T states. So to execute out FF55H, it requires 13 T states now. So now if you just add 3 to the previous, so the total number of cycles it is taking between two memory write signals is, instead of this one, instead of 10 you are going to write it as 13. So 41 plus 3 is nothing but 44 T states it requires. 44 T states means 44 into 0.2 microseconds. Each cycle is of 0.2 microseconds duration because microprocessor is operating at 5 MHz. So 44 into 0.2 is nothing but 8.8 microseconds it takes. So the time required between two memory write signals is, okay, it is 8.2 microseconds. If 3 wait states are introduced, it is 8.8 microseconds. Thank you.